What's up, everybody? It's Papa Bale. Welcome to the channel. We're taking a look at the Deadpool Rotor today. It's a 3-cylinder neodymium N52, 120 degrees. And I'm turning off the power real quick so I can show you the rotor. See, and if you look at it like at an angle, you can see Deadpool.
Yeah.
Sweet. Alright, so charging a cat bank, we're using, I don't think we're going to get much energy with these magnets off of this coil. So I'm going to turn it up to, we'll start at 6.5 or so. Alright, I think I'm going to have to raise it up. Because that did not start. Alright. There it goes. Just needed to go a little bit faster. Since it's such an acute area with the cylinder magnets, it's a very small area that's affected by the magnetism.
Right.
It's very acute. But see, as you can see, we're only drawing 200 milliamps with this so far. And it's a little low, so I think I'm going to raise it up. And I'm going to turn up the power a little bit. 9-volt battery. Still only drawing 300 milliamps. That's awesome. Little scooch. Come here, Tiggs.
Yeah. Yep.
Don't need you getting into wires, okay, buddy?
Hey, everybody. Welcome in. Thanks for dropping in. Drop us a like. Subscribe if you like electromagnetism, experiments, and pulse motors.
Alright, so we are definitely at 9. We're half an amp in. I don't think we're getting much energy off of the coil, this coil though. Yeah, okay. It's trying to get to 0.58, but it's it's not working very good.
Brian Burgess is in the house.
What's up, Brian? How's it going? All right, welcome. So this, for generating that type of power, this rotor is really bad. Or it's a little low, but I think it will still be bad even after I raise it up. But it's got like the best power rating out of all my rotors right now. It's the lowest amp draw out of all of them. "12-volt system. You're getting a lot of power going to the Trifilar now. But the Trifilar's hooked up to the secondary. So as you can see, the amount of voltage going through the Trifilar is a lot more now. But I had it turned up to 12 volts. But we're still only getting a minuscule amount into the cat bank from this coil off of this rotor. So I think what I'm going to do, I'm going to put the 2-magnet rotor on. It's got more powerful, more area effect magnets. It's because they're cubes instead of the cylinders. I think it's going to do a way better job of generating off of this coil. But this is an awesome rotor.
Yeah.
These magnets are cool. I like them.
Hey, everybody. Welcome to the channel. Thanks for dropping in. This is Papa Bale. We're working with pulse motors today. Let us know if you have any questions. Drop us a like, subscribe.
So it's almost perfect, but it is resting on the thing. So I gotta get the thing out of the way. It's a flange coupler. It's like if you wanted to attach your shaft to your rotor, you would screw this thing into your rotor and then tie down the nut onto the shaft, and then boom. It's a pretty solid connection. Because you get 2 nuts per coupler. 2 holes. There's a hole on each side of this shaft attachment here. At least that's what I would do. I would get the little M.P.H screws, and screw it in, whatever it was made out of. Alright. Oh yeah, we're already up to 58. It's down to 57. So what happens here is that the energy collected from the coils goes through this cap bank and then into the other cap bank. So it takes the AC, turns it into DC, and then puts it in the DC cap right here. So that's basically how it breaks down. Now I think that the other side something's wrong, so I might build a circuit real quick, just to test, like if that transistor is good. Let me think here. What do I want to do? I might do this one. It's a little off balance, but it's just floating there. So, I mean, all the pressure coming off this one kind of pushes it that way. I could fire up the other coil, but I need to like make sure that it's not. Here we go. This is the one.
Hey everybody, welcome to the channel. Thanks for dropping in.
Hello, hello. I need to get my screwdriver now. It's over here on the desk. I think I only have like 3 functioning transistors left. And I got some reed switches. Now, let's get these out of the way. I should probably turn that down before I get cracking on messing with it.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale. We're working with pulse motors today. Let us know if you have any questions. Drop us a like, subscribe if you like this kind of content. Thank you for coming.
Thank you so much. Appreciate you guys. Alright, so yeah, that's a nice strong suction right there. Alright. I guess we just start by unscrewing all this stuff. What that thing is awesome. Very heavy on the outside, so it spins like a flywheel.
Hey everybody, thanks for dropping in.
Hello, hello.
Let's see if we can get those likes up to 10. We get showing 3 right now. Thank you guys for the likes. Appreciate y'all.
Appreciate it. Here we go.
If you guys love DIY stuff, think about subscribing. We work with pulse motors, electromagnets.
Heck yeah. All right. Take this one. And we'll go. I'm going to connect this to the base of the transistor, which in this case is the yellow wire. Oh, I gotta get, is there one here? A light of some kind. Here we go. I know I put one up. Well, this is a halogen bulb, 120 volts. And it's going to go across the collector and the emitter.
Hey guys, thank you for the like.
Hey, hey, thanks.
Let's see if we can get those likes up to 10. Welcome to the channel.
So this light has a lot of purposes and a lot of hypothesis that goes along with it. But it does make the motor run better. So that much is a fact. All right, we're almost there. And then we get to see if the transistor is good or not. You know?
Let's see if we can get the likes up to 10. Let's see if we can get the amount of people in here up to 150.
Let's see if we can do it.
That would be amazing.
Oh yeah, that'd be fun. That'd be awesome.
We're up at 60 people right now. Appreciate y'all. Let us know if you have any questions.
Right here. This is the one we want for this connection. And then the ground for the trigger, because the base is already hooked to the one end of the trigger. We can use this wire. And that's going to go to the emitter. And this is our final connect. And this is basically the most simple transistor connection you can do that's sane. If you don't put the light in there, I don't see it working. But other than that, it's the most basic. All right.
And that one just stopped from when you cut it off a long while ago.
Oh, that one?
Yeah.
Yeah. Okay, it looks like the transistor is bad.
Mm.
Yeah. Yeah, when you're pulling like 200 milliamps and you haven't started your motor yet, that means you have a bad transistor.
Yeah.
Or there's something, the flow is on, so you have to regain control.
Hey, thanks for the likes, guys. Appreciate it. Let's see if we can get the likes up to 10. And you can hit those reactions too. Let's see if we can get 150 people up in here.
Let's do it.
Let us know if you have any questions.
Man, I can't see that. All right, that looks good. It does look good. All right. I don't want to put the PNP in there. I mean, the worst thing that could happen is you get a little smoke, but I hope I got that in the right hole. All right. Zero, zero, zero. That's what you're looking for when you turn on the power.
Nice. That was nice troubleshooting. And there we go. And troubleshooting in experimentation is, comes with experience.
Heck yeah. So it was a transistor that was popping wrong, and this one's good. So I'm thinking that the Trifilar energy that's going to come out of the strand now is going to be a lot better than it was.
Yeah.
All right. So let's hook it up then. Well, yeah, Trifilar is good. We can hook that up. And it's going a lot slower. I mean, it's a lot slower because it's a lot bigger coil than the one across the way here.
Right.
This one's built for speed and power. It's a 1 millimeter drive. This is a 20 gauge drive. That's like at least twice as long. All right, so I need to get 2 connectors. Need to scavenge.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a comment if you have any questions about the build. And we appreciate y'all dropping in. Drop a like and subscribe if you guys love pulse motor do-it-yourself content.
All right. You can just love me, my bro. I'm cool with it.
Yeah, straight.
All right. We got 1. We needed 1 more, and then we can hook up the Trifilar strand to what was hooked up to before.
Right.
Before we cannibalized whatever we did to get those. All right, so this is the end. So this will be the negative. Our AC2. Oh, there is one just chilling here. I didn't see that.
Nice.
And it is already hooked up to the other end of the 22 gauge strand. That's typical of me. Totally forget about it. All right, but I did unhook everything in a hurry, so I'm not beating myself up. All right, and this is AC generation. So we're gonna hook it to the AC side of the cat bank. It's a cool little cat bank because it goes in the AC capacitors on one side, then it gets rectified, then it comes out the DC capacitors on the other side. So it's all smooth and usable when it comes out pretty much. Now I feel like there's a tremendous load on it right now from the Trifilar connection because of the cat bank. That's just my hypothesis. All right, now we'll turn it on this side. Seven and a half. Get a reading, see if we're doing the right thing. Oh wow, yeah. So I'd say it's at like 10 seconds, maybe less per tick. And that's good. I mean, it's not stupendous, it's not over unity good, but it's good. It's it'll do for now.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe if you like this kind of content. We're working with pulse motors today. This is Papa Bale. Drop a question if you have any questions or comments about the build.
So both of these coils right here, this coil and this coil, are both Trifilar coils. Right now this Trifilar is running this motor and this Trifilar is charging this cat bank. So that's awesome. That's 2 practical uses for what I would consider an extension or exponential energy. You know, energy you have just because you added something. But I want to go on further to say that if I hook up the standard output, that it'll drop the amount of energy in the Trifilar, because a lot of that current will have a place to go, and it just, I think there's a lingering, I'm not exactly sure, but it's because the Trifilar wire is in proximity to the drive wire and the trigger coil. And all three of those wires interacting has a transformer-like effect for the Trifilar strand. So just for it being there, you get a charge. Just for it being on, you get a charge. And then of course you get your magnet generation from the magnets passing the coil. But the energy that I'm talking about is a continuance of the energy from your power source. It's like legit usable energy, and you can just continue it on, and it works like that. You just hook it up to the collector with a diode so it doesn't go back on your transistor, and bam, you got 11 or 12 volts going on to the next pulse motor or whatever you're going to do, charge a cat bank. It's up to 6.2 now. It's going pretty good. Now, what would be really interesting is if I hook up all of the outputs that are available to this one cat bank. Because there aren't any diodes, there's a strong possibility that you'll get some backlash. You'll short out, like instead of just shorting out one coil, you'll short out three. You know, yeah, I don't know. I'm just hypothesizing what would happen if I hooked all the outputs to one cat bank. And I think ultimately you're going to link all of those outputs together, and it's not going to be a good thing. Ultimately, you got to put diodes in at least, so that it doesn't connect all of those outputs together. Because you have a little wire sticking out of the cat bank at each end, and that's the thing that would connect everything, is that little wire. So, and it's a 20 gauge wire, it can do it. Wow. But right now, currently, we have this coil and that coil's Trifilar hooked up to this. And what I think is going on is that this coil entirety and that Trifilar they're linked now. They're either, if not shorted out, there's definitely some lag or drag there, just because they're linked together. But if I put diodes on, say, these two wires right here, which I'm not going to do, we don't need to do that, it would go faster. I know it would.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop a like, subscribe, let us know if you have any comments.
But in its current state, I think it's charging rather fast, so I'm going to leave it alone. And I love how fast this one gets going for secondary. I like that. It's not too fast, but it's not too slow either. Because this thing, when it gets going too fast, it tends to throw a shoe. Magnet gets flicked off. And I'm telling you, man, the amount of force is no joke, because Gorilla Glue, crazy Gorilla Glue, clear Gorilla Glue, and they were taped in, and it still popped out because it was going so fast. And it wasn't really going that fast. It's just like flywheel on the end. So the inertia or the whatever the force was that was causing that, it was just too strong for the glue and the tape. I get excited when I talk about that stuff. Because there's a little bit of danger involved in a bad design, you know? And I realized too late that the design wasn't good because there's nothing really supporting. The only thing that's keeping them pressured in there is the tape. And the only thing that's really holding them in there is the glue. And if you get any force going on the, toward pushing outward, it's going to throw magnets eventually.
Welcome in, Society of High Sciences.
Hey, what's up, man? You'll see, like this design right here, you got all this preventing it from, but I mean, you get going fast enough, this is, if there's any movement in here, that's not enough.
Hey Leon, welcome in. These are pulse motors. We're running pulse motor electromagnetic experiments.
Heck yeah. So, let me get this straight. This coil is sitting here collecting AC, putting it through this cap bank into this cap bank. This is a Trifilar coil. It's got 20 gauge drive, 22 gauge Trifilar, and a 30 gauge trigger. And all that's whipping and going into the same cap bank as this coil. And that's charging this cap bank and the meters right here, and we're already up to like 7 volts. It's not the fastest thing in the world, but it's a lot faster than some of the charging that I've seen.
Yep. It was 5 something last time we looked at it.
And that's on 730 turns of 22 gauge in a transformer-like state. Because there's cores in both of these coils, so each one of those Trifilars utilizes the core. Let me think here. This is being run off the Trifilar of this coil. A lot of the speed off the rotor, no lie, is coming off of this coil because it's the 1mm drive. I think it's 7.5 volts parallel, so each coil's got 7.5 volts going into it. This one is, going on 600 milliamps because it's so fat. The wire is so fat. And then that one over there is 350 milliamps. So they're not equal. You can respect the differences though. The cap banks here are the same. That's the cool part about this. I had 2 of these bad boys, and I don't think it'll be working out as good as it is without it. It's very awesome how it smooths out the energy, and it takes the AC, rectifies it, and stores it, and it's a cap bank. I mean, literally, but it's a multi. It's got AC capacitors and DC capacitors, so it's a rectifier as well. And then it's got the bridge rectifiers. I think they're in like stacks of. There's 4 rows, so there's 4 AC capacitors, there's 4 bridge rectifiers, and there's 4 rows of DC capacitors. So that's how it's connected. That's awesome. And like the amount of energy that's being generated by this Trifilar is a lot more than what this motor is spending. So we could send the energy on again and it would continue. This one is a lot less, it's more dim. That's because there's a lot more room for the energy to flow. The cap bank is vast. So,
Hey everybody, welcome to the channel. Thanks for dropping in. We are working with pulse motors today, doing electromagnetic experiments and taking some readings.
wonder where these are hooked up to. Oh, they're not.
Let us know if you have any questions, and drop a like and subscribe if you appreciate this kind of content.
Any ideas where I should hook up these probes for my other multimeter? Anybody want to see anything?
We are working with pulse motors today, folks.
So I'll hook it directly up to the Trifilar.
And this is all DIY, you know, self-learning, experimentation.
So like, I gotta cut the power to do this.
On both of them.
Yeah, you mind flipping that switch? Thank you. All right. Now, just for good measure, stop the rotor here.
Oh, we got to sneeze.
Bless you. Bless you.
Pardon me. Yeah, check out the channel, subscribe. You can check out the learning journey. It's been pretty cool, 18 months. And it's
Yeah.
all documented. And we appreciate the community. There's so much knowledge in the community coming through when you guys drop the comments in. We appreciate y'all.
Heck yeah. Now here's a question. I've got 4 ferrite cores in the opposite coil of this one. And then I've got 1 soft iron core that's twice the length of the coil in this one. Which one do you think is better? I think having the multiple cores is a good thing. Alright.
Yeah, I got a nice shot of the quad core.
Yeah, the quad core, yeah. But, I mean, yeah. Yeah, the quad core.
Welcome in, Seputar. Thanks for dropping in. Let us know if you have any comments.
So, we got 2 cat banks. We got 2 coils. We got 1 dead battery. We got 2 dead batteries, actually. But I think both of these cat banks are supposed to dump their energy into one place. So basically what I'm thinking is, instead of having the Trifilar output, we have a Trifilar drive with two Bedini type outputs that would hook to these cat banks, and then it would filter back into this big cat bank right here, which would be running the power source or the battery. Or we take the big cat bank out and we just hook these things to their respective batteries, right?
Separate question, but Brian asked, any tests with the magnetic core yet?
I have not tested. Well, I mean, I did back in the day test the magnetic core, but nothing recently. And that it could be pretty interesting. I haven't tested one recently though. You mean a magnet core or a magnetic core?
Magnetic.
Magnetic core? These are magnetic.
Oh, I see.
These are very magnetic. But you meant a magnet core, right? A core that's an actual magnet? I used to do
Magnet core, yep.
Yeah. I used to do experiments like that. Yeah. Because I have the cylinder magnets here. And they fit nicely in the coils. So I tried it. And I learned a lot about making coils since then too. So it would probably work out better now than it did then.
Mm-hmm. Another evolution to watch on the channel. Like and subscribe if you appreciate this kind of content.
Alright, so 7.5 volts.
Stored up. It was 6.9 last time we looked.
Wow, that's quite a bit.
5.8 before we looked there. And then there's another input.
Oh, we gotta turn this one on and check the AC reading on the Trifilar. So 3.5 volts are in the capacitance of the coil. So this is the reading before it gets to the cat bank, and there's actually 3 1/3 volts of AC that are latent in the coil. So I could actually, at this juncture, hook up another cat bank, and it would fill up as well.
Okay.
What else can we look at? Like the DC, how much DC is flowing? Oh, I don't want to grab that. How much DC is flowing, and then I'm like, okay.
You want this one cut off?
Yeah. Yep, good job. Alright. Back that off a little bit. We'll get the DC reading now. In order to do that, we need to hook this one. Pardon my tremor, folks.
Appreciate you, Beverly. Thanks for the comments. Thanks for dropping in.
And then this one is going to get hooked. This one, and we're going to get very low reading, I'm thinking, because of the motor spinning right now. So it's sucking the energy out. Any energy that gets put in is getting sucked out. But it's very low reading. All right. good. Now let me get the other one. I love how it just keeps going, like an Energizer bunny.
Mm.
Move that up. See, this coil by itself doesn't do much, but in correlation with one of the Trifilars, it's awesome. It's like a perfect boost. And then I need to make another one, and then try for like a relay or something. So I have another one of these on the opposite side. I think that will work out just great. Oh yeah, we were looking at the DC reading.
Thanks for the like. We just got to 10 likes. We appreciate y'all. Let's keep it going. Let's see if we can get it up to 15.
So the 2-magnet rotor is generating 20 volts in the cat bank of DC electricity on top of what's being spent on the motor. Awesome. So what I want to do now is hook up a different rotor. Go ahead and flip that switch for me, bro. Thank you. All right. Now, I had a hypothesis the other day that more magnets means more energy on the Trifilar strand. But not without spending more, so it's a give and take. It adds up to more energy being generated, but at the same time, it's proportionately probably the same amount.
Wow, you guys are in tune.
All right, can you flip it on? You know, maybe the meter readings are going to be higher. Yeah, they're a little higher already. They're virtually, 7.5 in. They're a little higher already. It's just starting to pick up a little bit. Well, that's starting to go down. I don't know. Don't know. Okay. So we're at 8 in the cat bank now. That's awesome.
Nice.
We are pulling 1.1 amps though. Might turn that down to like 6. I like that rotor. That's good. I don't want to mess with that. Alright, so what I think I want to do,
Hey everybody, thank you for dropping in. Welcome to the channel. Drop a like, subscribe. Let us know if you have any comments about the build.
yeah, that's what we're going to do. We're going to hook up this cat bank to this battery, and then we're going to, well no, that won't work, will it? Because these are more like pathways. They're not really cat banks. I mean, they do store a little bit of energy, but it's really kind of an in-out system. It's not like this cat bank, which is designed to store energy. And I really don't want to hook it up the same old way again. So I see. All right, so we will use. Huh. Let me grab the other battery. Be right back. All right. So my idea is you need to have this cat bank at the start. So in order to start it up, you gotta have this cat bank. But after that, the other two cat banks should take over. Hey, little guy. Hi. I don't know. Seems like it's worth a shot, in my opinion.
Alright, then we're gonna wrap it up after that one.
Okay.
Yeah.
All right, we got 2 more connections. That's
Yeah.
awesome. All right.
Yeah, this one's got a ton of mass.
Yeah, there's no power on right now, so this is going on pure momentum. All right, let's see here. So these are hooked up to the AC. Alright, so DC is going to get hooked up to the battery. Negative. And I need to learn how to do a PNP circuit because I got so many PNPs.
Yeah.
I got so many. It'd be a waste to have to throw them all away. Or maybe I could, well, we'll talk about that later on. Now DC right here. All right, so now and then I'm thinking, I hope I got this right. I might have to swap some stuff. It'll work itself out. Oh yeah. You know? Let me just see if spinning this is going to do anything. So we are generating about 2 volts of DC, and that's going up. But it is a cap bank. All right. All right, so what we're looking for is for, I think these ones are hooked up to, I don't know. I believe it's this one that's hooked up to that coil through that battery over there. And then this one is, I guess, priming it. So, how much DC voltage is on that meter right there?
It's off.
Oh, it's been turned off.
Yeah.
Let me turn it on real quick.
Mm-hmm.
And we'll get. So it's spending as quickly as it's generating, which is okay. It's not at nothing and it's not at exponential amounts, which is good actually.
Nice work. Hey everybody, welcome to the channel. Thanks for dropping in. Drop a like and subscribe if you like this kind of content. Let us know if you have any questions.
I'm wondering if I should hook up this power to that battery, and then there'd be no primer. But I'll, you know, if you spin it, I'll just do it real quick. And this will basically complete that experiment. By the time I did that, good Lord, so much experimentation. All right. Well, I knew that was going to happen. So, I mean, what we can do is take a break. So, thank you very much, everybody. And peace out. Have a wonderful day. And I'll check you later. Bye now.